Next, we want to look at equations that involve absolute value. Here's our first example. Let's solve the equation, the absolute value of the quantity x minus 2 is equal to 5. Now, we solve this equation by thinking of the absolute value, or thinking about what's inside the absolute value as being either positive 5 or negative 5. That's the only way we can get the absolute value of a quantity to be equal to 5. So that means that x minus 2 must be equal to negative 5, or x minus 2 is equal to positive 5. In either case, the absolute value of x minus 2 turns out to be 5. So I get two separate equations to solve. I'll add 2 to both sides of this equation and get x is equal to negative 3. And I'll add 2 to both sides of this equation and get x is equal to 7. So our solution set for this equation is negative 3, 7. Either of these two numbers, if I replace x with them, gives me a true statement. If I put in negative 3 for x, I have negative 3 plus negative 2, which is negative 5, the absolute value of which is 5. If I put in 7, I have 7 minus 2, which is 5, the absolute value of which is 5. So two solutions. Let's look at our next example. Before I solve this equation, I need to isolate this absolute value on one side of the equation, so I'll begin by adding negative 1 to both sides. That will give me the absolute value of 3x plus 4 is equal to 7 plus negative 1, which is 6. Now, the only way the absolute value of 3x minus 4 can be equal to 6 is if 3x plus 4 is equal to 6, is if 3x plus 4 is negative 6, or 3x plus 4 is equal to positive 6. So when I say the absolute value of this quantity is 6, it means that this quantity is either negative 6 or positive 6. Those are the only two numbers whose absolute value is 6. Solving this equation, I add negative 6 to both sides and end up with negative 10. Divide both sides by 3, and I get x is equal to negative 10 thirds. There's one solution. Or add negative 4 to both sides here, and I have 3x is equal to 2. Divide both sides by 3, and I have x is equal to 2 thirds. So I get two solutions. X is equal to negative 10 thirds, or x is equal to 2 thirds. Either one of those two numbers, when I replace x with them in the original equation, will give me a true statement. That is, the absolute value of that quantity plus 1 will always turn out to be 7. Let's look at one last example. The absolute value of 3x plus 1 is equal to the absolute value of 2a minus 4. Let me say that again. The absolute value of 3a plus 1 is equal to the absolute value of 2a minus 4. Well, the only way two numbers can have the same absolute value is if the numbers, which in this case are 3a plus 1 and 2a minus 4, are equal to each other, or if they are opposites of each other. So I reason out this equation this way. I have two expressions whose absolute values are equal. The only way that can happen is if the two expressions are equal or if the two expressions are opposites. In this case, I'll add negative 2a to both sides to begin with, and a negative 1 to both sides, and I end up with a is equal to negative 5. Over here, I'll have to remove these absolute value symbols to begin with, so I have 3a plus 1 is equal to negative 2a plus 4. Now I'll add 2a to both sides and get 5a, and I'll add negative 1 to both sides and get 3. Divide both sides by 5, a is equal to 3/5. So I have two solutions. A is equal to negative 5, and a is equal to 3/5. So I reasoned this one out in a manner similar to the way I reasoned out the previous two problems. These two expressions right here, their absolute values are equal only one of two ways: if the two expressions themselves are equal, or if those two expressions are opposites. So that's a quick look at some equations that involve absolute value.